components of diesel engine, that is two-stroke diesel engine, are nozzles or fuel injector. The nozzle is also called fuel injector, and it has also three valves: exhaust port, intake port, and transfer port. So these are the three valves. And we have deflector, piston, and connecting rod, and crankshaft, and crankcase. So these are the components of two-stroke diesel engine. So it is similar to that of this two-stroke petrol engine. Instead of, we use fuel injectors instead of spark plug, and here only air mixture will enters. So you need to draw a diagram, a figure like this in examination, and replace this fuel injector and this spark plug and use fuel injectors. Okay. So let's start the section. The first one is, so what is two-stroke engine? We get power in two-stroke of the piston, that is, or one revolution of the crankshaft, that is two-stroke engine. It consisting of total two stroke. First stroke involves the suction stroke and compression stroke, and the second stroke includes power and exhaust stroke. Okay, so let's start about the power stroke of the piston, that is suction plus compression. So as the piston start raising from its bottom dead center position, it closes the transfer port and exhaust port. The air which is already there in the cylinder is compressed. So as you can see, suppose this is our diesel engine, and here we have fuel injector. Okay, so initially our piston is at bottom dead center, and when the piston when the piston moves from the bottom dead center to the top dead center, what will happen? There occurs a pressure difference inside this crankcase. So what will happen? The air enters into the crankcase. That means inside the crankcase it is low pressure, and the atmosphere it is high pressure. So the air will enters into the crankcase through inlet port. And you can see when the piston moves upwards, what will happen? The exhaust port and the transfer ports are closed. Okay, and in this case, we have suction plus compression. That means suction means a proper amount of air is sucked from the atmosphere and it get into the crankcase, and compression means the piston compresses the air inside the compression chamber. So that is called compression process. Okay. At the same time, the vacuum is created in the crankcase. As soon as the inlet port is uncovered, the fresh air is sucked into the crankcase. During this stroke, the suction and compression are completed. So this is all about the upstroke of the piston, that is suction plus compression. Okay. So when the piston moves from bottom dead center to top dead center, the inlet valve, the exhaust valve, and transfer ports are closed, and so there occurs a vacuum inside the crankcase, and a proper amount of air will enters into the inlet port, and it enters into the crankcase. Okay, and at the same time, the piston moves upwards, and they create a high temperature and pressure inside the combustion chamber. And the next one is downward stroke of the piston, that is power plus exhaust. Okay, so slightly before the completion of the compression stroke, a very fine spray of the diesel is injected into the compressed air at high temperature. So as you can see in this figure, suppose this is our diesel engine. Here instead of spark plug we use fuel injector. So when the pressure increases, the temperature also increases. So that equation, that is PV is equal to mRT. If pressure increases, temperature also increases. So at the end of the compression stroke, what will happen? The fuel injector ignites the apply the fuel, and what will happen? The air fuel mixture ignites, and due to that, the piston moves from the top dead center to bottom dead center. That time the fuel ignites spontaneously. Thus, pressure is exerted on the crown of the piston, is pushed into the downward direction, and produce some useful power. So in that power stroke, what will happen? The piston pushes down from the top dead center to bottom dead center. And the downward movement of the piston will first closes the inlet port, and then it will compresses the air already sucks into the crankshaft at the end of the power stroke. So due to this downward movement of the piston, what will happen? It closes the inlet port, and due to that pressure created inside the crankcase, if the inlet valve is already closed, so due to that, the fresh air from the crankcase enters into the combustion chamber through this transfer port, and it drives off the exhaust gas from the exhaust port. Okay, due to that pressure, what will happen? The fresh air from the transfer port enters into the combustion chamber, and the fresh air drives off the exhaust gas in the combustion chamber. So this will happen in the downward stroke, power plus exhaust stroke. Because during this stroke, power and exhaust strokes are completed. So this all about the two-stroke petrol and diesel engine. And we have one more term, that is the PV diagram. As you can see, the x-axis represents the volume and y-axis represents the pressure. You can see this from left to right. That means the volume increases. From bottom to top, the pressure increases. Okay. So first, the exhaust valve closed and inlet valve closed. So we can see from. Can you see this mouse pointer? Anyone?
Yes.
Yes,
Hello.
sir. Yes, sir.
Okay. So you can see this compression line. Okay. So this compression line represents the pressure increases, the volume decreases.
Yes, Mike
That
Banker.
means,
Yes.
okay, the pressure increases, the volume decreases. That means the piston moves upwards. That means the pressure increases, the volume of the inside chamber decreases. Initially, our compression chamber is at this position. So we have a large volume. If the pressure increases, what will happen? The compression chamber volume decreases. And at this maximum pressure time, what will happen? It ignites. That means we ignite the fuel, and that time what will happen? The pressure stroke occurs. That means the piston moves downwards. Again, the volume increases. That means expansion. We get the power, and again the exhaust valve opens and the combustion gas moves outwards. So it happens like a cycle. So this is called the real Otto cycle, diesel cycle. Okay. Any doubts? Cycle of operation in four-stroke engine, that is petrol engine. So who invented this petrol engine?
Okay.
Nicholas August Otto invented this petrol engine, and it works on the principle of Otto cycle. Okay, so in four-stroke engine we have four-stroke. That means one upward movement of the piston from the bottom dead center to top dead center, that is called first stroke, and again return back and again moving, that is the the cycle of operation completes in four stroke of the piston, that is two complete revolution of the crankshaft. So this is our crankshaft and this is our piston. The piston moves four times and the crankshaft completes two revolution. So within two revolution we get power. So that is called four stroke engine. Okay. Here the working cycle is completed in four stroke of the piston or two complete revolution of the crankshaft. In this engine, the valves are used and complete compression of the charge takes place. So instead of ports, we use valves here. That is intake valves and exhaust valves. In two-stroke engine, we use ports instead of valves. That is inlet port, exhaust port, and transfer port. In this case, four-stroke engine, we use valves. That is inlet valve and outlet valve or exhaust valve. Always remember that. Okay. And first of all, I will give you the what are the components used in this four-stroke engine. The first one is inlet valve. Second one is exhaust valve. In the case of petrol engine, we use spark plug, and this is the crankshaft. This is the connecting rod, piston, and this is the combustion chamber where the combustion takes place. Okay, so we have four stroke. The first one is intake stroke or suction stroke. Second one is compression stroke. Third one is power stroke. And the fourth one is exhaust stroke. Okay, so you can see 0 to 180 degree. So 0 to 180 degree means the movement of crank from 0 to 180 degree. One stroke occurs. From 180 to 360, second stroke occurs. That means one complete revolution completed. And the power stroke again 360 to 540, and exhaust stroke 540 to 720. So here completed the two complete revolution of the crankshaft and four stroke of the piston. So that we get a power stroke. Okay. Any doubts?
No, sir.
Okay, good. So let's move on to the section. The first one is suction stroke. Okay. So in this figure, this is the suction stroke. In this suction stroke, what will happen? The piston moves from the inlet valve is open and the exhaust valve is closed. Here, the inlet valve is open in suction stroke and the exhaust valve is closed. And when the piston goes downwards from the top dead center to the bottom dead center, the vacuum is created inside the cylinder and the charge is drawn into the cylinder. So in the suction stroke, what will happen? The piston moves from the top dead center. So this is the top dead center and this is the bottom dead center. Top dead center to bottom dead center. What will happen? There creates a vacuum inside this combustion chamber, so that a proper amount of air fuel mixture from the carburetor is entered through this inlet valve or intake valve. Okay, and this will continue till the piston reaches bottom dead center. That is, the crank rotates through 180 degree. So when the piston, so this entering continues when the piston reaches the bottom dead center. That means the cranks completed one half rotation, that is 0 to 180 degree. So this is called suction stroke. Okay, and the next one is compression stroke. So during this stroke, the inlet valve and the exhaust valve are closed. The charge is compressed as the piston moves from bottom dead center to top dead center. So in this second stroke, that is compression stroke. That means here both the valves are closed. That is, intake and exhaust valves are closed, and the piston moves from bottom dead center to top dead center. Here again a half rotation completed by the crankshaft, that is 180 to 360. So total one complete revolution completed by the crankshaft. During compression, the pressure and temperature rises. This rises of temperature and pressure depends upon the compression ratio. So in this here, what will happen? The pressure increases. That means the piston moves upwards. What will happen? The pressure increases. If the pressure increases, the temperature also increases. By using the equation PV is equal to MRT. Pressure increases, temperature also increases. And here you can see the one term that called compression ratio. So what is compression ratio? Does anyone knows about compression ratio? Anyone? Hello?
Maximum volume to minimum volume.
No. So compression ratio is the ratio of, it is a summation of suction volume plus clearance volume all divided by clearance volume. Suppose 6 is to 1 is the compression ratio. That means 6 is to 1. 6 means the entire volume of the combustion chamber and 1 is the clearance volume. Okay. Any doubts?
No, sir.
No,
Okay,
sir.
No,
No, sir.
no, sir.
I will show you. Okay, so that's all about the compression stroke. So generally for SI engine, the compression ratio varies from both 6 is to 1 is to 9 is to 1. That is, 6 is the entire volume. That is the summation of swept volume plus clearance volume by clearance volume. Swept volume plus clearance volume is the entire volume by clearance volume. Okay, so 6 is to 1 to 9 is to 1. It changes from 6 is to 1 to 9 is to 1. Here the crank completes one complete revolution. So we already done that. That is 0 to 180, 180 to 360. So one complete revolution completed. Okay, and next one is power stroke or expansion stroke. So during this stroke, the inlet valves and the exhaust valves are closed. The charge is ignited by means of spark plug and results in high temperature and high pressure, pushes the piston from top dead center to bottom dead center. This is called power stroke. As you can see, right now our piston is at top dead center. Due to that compression, we have high pressure and high temperature at this section. Okay, inside that we have air fuel mixture, and these two valves are closed. At the same time, what will happen? The spark plug ignites. So due to that ignition, instant heat produced, and the air fuel mixture burns. So due to that burning, what will happen? The power stroke produce, and while hitting the piston downwards, so we get that power. So right now our piston is at bottom dead center. So again our crankshaft completed one half rotation, that is 360 to 540 degree. Explosion force piston downwards. So during the compression, the pressure and temperature rises. This rises the depends upon the compression ratio. Okay. Okay. The crank completed one and a half rotation. That is 0 to 540 degree. That is one and a half rotation. The next one is exhaust stroke. So in the stroke, the inlet valve is closed. The exhaust valve is open. The piston begins to move from VDC to TDC. The exhaust valve is open through, and so again, in exhaust stroke, what happens? The inlet valve closed, exhaust valve open. So the piston moves from bottom dead center to top dead center. What will happen? The combustion gas moves through this exhaust valve. So our crankshaft completed 540 to 720 degrees Celsius. That means the crankshaft completed 2 revolution, and the piston completed 4 stroke. So we already get the power also. So this is all about 4-stroke engine, 4-stroke petrol engine. So we completed the 4-stroke petrol engine, and next one is 4-stroke diesel engine, that is compression ignition engine. The petrol engine is called spark ignition engine, and diesel engine is called compression ignition engine. So like that, instead of this spark plug, we use fuel injectors in diesel engine. Again, in 4-stroke diesel engine, we get power from 4 stroke of the piston, that is 2 complete revolution of the crankshaft. Okay, and the components of this 4-stroke diesel engine are piston, connecting rod, crankshaft, crankcase, and piston intake valves, exhaust valves. And instead of spark plug, we use fuel injectors. Okay, and the inlet valve, the air is coming, not air fuel mixture, only air is coming through this inlet valves. The working is similar to that of this petrol engine. Instead of the spark plug, we use this fuel injector. That's the main difference. And the compression ratio of spark ignition engine is 6:10, while the compression ratio of this combustion ignition engine is 16:20. Okay, it is the main difference. In SI engines, that is in CA engine, a fuel pump and injectors are provided to inject the fuel into the combustion chamber. And instead of carburetor and spark plug, there is fuel injectors are used. Okay. The So let's start the section. The first one is suction stroke, second one is compression stroke, and the third one is power stroke, fourth one is exhaust stroke. So again, in suction stroke, what will happen? The inlet valve opens and the piston moves from top dead center to bottom dead center. Okay, and a proper amount of air will enters, that is fresh air enters into the combustion chamber. And in the case of compression stroke, what will happen? Piston moves from bottom dead center to top dead center, and it compresses while the 2 valves are closed, and it compresses at high temperature and pressure. Power stroke में क्या होता है? The power stroke, that means the fuel injector ignites, sprays the fuel like fine spray, and due to that high temperature and pressure, what will happen? It ignites, and due to that the piston moves downwards. So power stroke produced. And the last one is exhaust stroke. The piston moves from bottom dead center to top dead center, while leaving the combustion gas outwards through exhaust valve. So these are the cycles. So this is all about the cycle of operation in four-stroke diesel engine.